Hey guys, this is going to be 3.3 transformation notes. In class, we shifted around the papers, so it should be in the correct order, and if not, you'll see the order that should go in this video. So a function, it's going to be shifted horizontally, vertically, reflected, stretched, or compressed, and these changes are called transformations. Let me actually get a pen color. Okay. So we'll start off with the parent function of an absolute and do a couple transformations to it. So this is our parent function. I'm going to go ahead and graph it. I'm going to skip kind of past graphing the points, like explaining how to do it, because we did talk about the parent functions. It's absolute, and you can use your graphing calculator. So if you need the points for that, you can always use a table if you need to. Like, you always know the parent function is going to be at 0, 0. So you can do 0, 0, and then you can do -1 and then 1 and kind of like sandwich it and do it that way if you'd like to. But the first transformation you can see right here is a +2 being added to the outside of your absolute value. You can take a second, get your graphing calculator, and plug this into the functions and see what happens. I'm also going to show you right now. This 2, what it does is from the origin, it goes up 2 spots. So right here. And then everything else will be the same because, again, it's just the parent function right here with it being shifted up 2. So all the points will be the same for your function on the sides. Like so. Like so. And then this third one, h of x, is x minus 1, but notice the difference. It's inside the parentheses. When you see it inside the parentheses, hopefully you remember it's shifting left or right. And it's the opposite of what you think. So if it's a -1, it's going to be shifted to the right one instead of to the left one. So from the origin, 0, 0, it's moving to the right, and it has the same slope on both sides. Which I will try to draw as straight of a line as I can, but we all know that I'm not very good at that. Okay, so notice the transformations. We have our original parent function, f of x, in the pink. In the blue, we have shift up 2, and then in the teal, we have a shift to the right 1. All of these transformations can be written into transformation rules. This first one is f of x, x plus h, and that is going to be inside the parentheses. So again, notice it's inside the grouping symbol. It's going to be sometimes absolute value or parentheses depending on the function. But any type of grouping symbol, if it's plus a value of h, it's going to be moving left that value. So left h, or h amount, whatever you'd like to put. Next one, x minus h, that's going right h times. When it's outside the grouping symbols, like these next two, this one is shifting up k amount, and this is going down, or k amount. All right, these next two. We will talk about horizontal later, but for right now, we'll just talk about vertical. Vertical is going to be outside values, outside your function. So let's say that this value of a is going to be a value that's greater than 1. If you have a value of a on the outside of your function that's greater than 1, this is going to be a vertical stretch. Okay? If I have b, imagine b is going to be greater than 0, but it's going to be less than the value of 1. It's going to be, for example, 1/2, 3/2, any type of fraction that's smaller than 1. So therefore, this is going to be a vertical compression. All right, so that's going to be stretching the graph vertically. You could also like look at the values and determine if it's horizontal compression, or sorry, stretch or compress, depending on the values. But vertical is always going to be the amount on the outside of the function. These next two are going to be reflections. So if it's on the outside of the function, this is going to be a reflection on the x-axis. There's that little saying of like, say if you are dating somebody and you're not going to invite them inside because you're not dating anymore, like you're inside your house, so you're going to throw them outside, not literally obviously, but if you have an ex, you throw them outside. So there's that little saying. So if it helps you remember it any easier, the value of x that's negative, it's going to be on the outside of the function. And then there's nothing to help you with y. So sad, I know. But if a function has a negative inside the grouping symbols, that's going to be a reflection on the y-axis, or about the y-axis. All right, so these are all the functions besides horizontal and vertical, but I will talk more specifically like halfway through the notes about that one as well. But if you do want to put it to the side, hold on. If I have f and then a of x and then f b of x, these are going to be horizontal. And for this one, if my value of a greater than 1, it's actually going to be a compression. It's the opposite of vertical. And then if it's 0, value b less than 1, this is going to be your stretch. Okay? So let's sketch some graphs. So the first one, this is a quadratic. So when I showed you guys the parent functions in the last notes, you do need to know what those are graphed, so that you know when you do transformations, all you have to do is shift the vertex up 1, especially if it's just something like this. So up 1, or sorry, that's a negative number, down 1, down 1. And your vertex for a parent function of a parabola is always at 0, 0. So I'm going to go ahead and graph the parent function just real quick, so you can see. Okay, so parent function's graphed. Now all I'm doing for this function is shifting it down 1. So all you do is move it, and then you graph your parabola like a normal 1, 2, 3 over 1, 1, 2, 3, like so. And notice it's going to be the same shape versus like the stretch or something, because it's a parent function. It's going to have the same width about it, but it's going to just be shifted down. Something like letter B, this is the same thing, but notice it's in the grouping symbols. So this is going to be left 2 from our parent function. So like in the purple one, it's starting at 0, 0, but if I'm going left, also I said 1, I'm pretty sure, but wrote a 2. That's what happens when I make a notes video like after school. All right, so I'm shifting left 1 with my parent function from the origin, shifting just left 1, and then I have the same coordinates. Over 1, up 3, 1, 2, 3, over 1, over 1, like so. This one's hard because the negative one's kind of smaller, but that will be if I shift it left. Again, you can like use your graphing calculator, or use a table by hand. So like if you were to do a table by hand, all you would have to do is do x, y for the function, and you could like plug in. Obviously, you know your vertex, since it's shifted from the original, it's going to be at -1, 0, and then you can pick points to continue on and graph your parabola that way. So you don't have to use a graphing calculator. Like, you can definitely do this by hand, like I've just been doing. I don't have a calculator next to me, so you can do this by hand all you want. All right, other than those two, those are my quadratic. I also have my radical, my square root graphs. So let me move this out of the way. It's the same thing. Your radical is your grouping symbol. So if it's under the radical, that's going to be the shifting left or right. If it's outside, that's going to be the up or down. So because I don't have a calculator on me, I'll just show you how to do it by table if you want, or you can just plug it into your graph. So my original parent function for my, like, radical, I almost said square root. I mean, well, yeah, we'll call it the same thing. It's basically the same thing. So I start at my origin. So I start at 0, 0, and then I'm continuing on. So if I have my value at 1, if I plugged a 1 into this table, I would have 1 plus 1, which is 2. So it's going to be at my value of 2. Or I guess I should, hold on. Let me take you guys back. Let me start off with the parent function, and then we'll go into the quadratic. So parent function would just be the square root. So we would have the square root of x. So my first quadrant or coordinate point 0, 0, and then 1 would be 1, and then I continue on with something like 4. 4 would be 2. 1, 2, 3, 4, 2. And so this will be my parent function for my radical. And then now let's talk about shifting it left 1, because I was making no sense earlier. Okay, so from my origin, I'm just shifting left 1, so it's just starting here. And so if you are shifting this left 1, you know that in your table, I'm going to erase this one. You can have your x, you can have your y. You know you're going to have the coordinate -1, 0, and because it's a radical, you know it's only going to the right. It's only just that part of the function. So you can pick points like 0, 1, 2, etc. So I'm going to pick 0. I'm going to pick, let's pick something easy. Let's pick 3, and that'll be about it. That's perfectly fine. I have 3 points. So 0 plus 1 is obviously 1. The square root of 1 is 1. Then I have 3. 3 plus 1 equals 4. The square root of 4 is 2. And so then I can graph my function like so. 0, 1, 3, 2. 1, 2, 3, 1, 2. And again, it has the same stretch, but it's just being shifted. So it doesn't really change much about the integrity of the function or what it looks like. And then letter B, this is going to be when I shift up to. So instead of at 0, 0 right here, I'm going up to. So 1, 2, and this is my point here. I can do the same thing. So if I have my table, I don't have a graphing calculator, I can say, okay, I know I'm starting at 2, 0, and I know I'm going to have to go to the right hand side, to my first quadrant. So I can pick 4, and let's pick 9. If I plug in a 4, that's going to be 2. 2 plus 2, or I can also just write it here so you can see. The square root of 4 plus 2, that's 2 plus 2, so that's going to be 4. Then I can plug in a 9. Square root of 9 plus 2, that's 3 plus 2, that's 5. So then I can plot my points as such. So 2, 0, 4, 4, and then 9, 5. So again, it still has the same integrity, the same shape, but it just shifted up. And I did pick different x values, but I just did that so you can see that picking them doesn't really matter as long as you have points to plot the graph. All right, so what if we have a combination of transformations? We have the value of 1 and then -2. This is going to have a left 1. This is going to have a down 2. Okay, so once I'm here, I'm going to go ahead and I'm going to put my vertex. So this is basically the vertex. This is H, this is K. I'm shifting my vertex -1, so left 1, and then down 2. So left 1, 1, 2, down 2. I don't have any type of stretch on my value of x, so I know I'm going to have to keep the same integrity of a parabola. So over 1, up 1, over 1, up 1, over 1, up 3, 1, 2, 3, over 1, 1, 2, 3. And then I can graph my parabola as such because I got 5 points. And then you're done. That's it. Again, you can check your answer with your graphing calculator. And then you can also use a table to check your coordinates as well. Okay? So maybe pause, take a second, go ahead and do example 3. Example 3 is absolute value. Okay? Think to yourself, okay, I know there's going to be two transformations. What are they? We have this one and we have this one. This is going to be left 2, and this is going to be up 1. So same thing, vertex h, comma k. So, but it's the opposite in the middle. So I go left 2, I go up 1, and absolute value always has a value of 1 slope unless a vertical stretch or compress is being done. So I'm going to graph it like so. And I'm done. I can double check by again. You can check with your graphing calculator. You can also check by plugging into a table. Either one. All right. We have basically been doing just shifting left, right, up and down. Now let's talk about if we reflect. Reflections are fairly simple. Again, you just have to memorize the coordinates of the parent function, and then if it's going reflection over the x or reflection over the y. So with my parent function, I'm going to do it in purple. We have r over 1, 1, 2, 3. I'm going to do some more points on this because I am reflecting. Over 1, 1, 2, 3, 4, 5, and then over 1, 1, 2, 3, over 1, up 5. Okay. So here is my parabola. Okay. This is the function of x squared. This one right here, like that little joke, that little thing I said, x is outside. So that means I'm reflecting over my x-axis right here. So imagine if you folded this graph like, what is that, hamburger style, or, yeah, hamburger, hot dog, I don't know. But you know what I mean. If I fold it over the x-axis, okay, it's going to be basically the same points, but reflected negative. So if you were to go about this on a table, your first quadrant or coordinates of your x squared, oh, I need a pen, is, let's say, this is my x, my y, and then this is negative x squared, okay? I'm changing the value of my y coordinates because I'm reflecting them, right? So my first coordinate is 0, 0. That doesn't change because 0 can't get negative. But notice I have the point 1, 1, but I also have the point 1, negative 1. Okay? So if I'm looking at my points of 1, 1, 1, negative 1, if I'm reflecting over the x, I'm also having them here as well because it's reflecting over. Okay, so I have a, which I am realizing now, oopsies, I wrote the wrong negative on there. So you're like, what the heck? So my function for my x, y, for my negative x squared, I still have 0, 0, but I actually have a 1, negative 1, and then a negative 1, negative 1. It changes the value of the y when it's reflecting over the x-axis. So that's a trick too. If you're just filling out in the table, all you're doing is changing the sign of the y if you're reflecting over the x. If you're reflecting over the y, you're changing the sign of the x value, okay? So I'm reflecting down. So this is over 1, 1, 2, 3, over 1, 1, 2, 3, and then over 1, 1, 2, 3, 4, 5. Or, again, you can also just make a table. So, like, if that's your business, there's multiple ways to do this by hand with a table, by hand by memorizing the reflection rules. Oh my gosh, also realizing how awfully I wrote that parabola. So, you know, it's fine. We're just going to have a lopsided parabola. At least my coordinates are written correctly. So again, graphing calculator, you can do a table, you can memorize reflection strategies. It's really up to you, whatever works for your cool and awesome brain. All right, now's the time I would take a second and I would sketch the graph of example 5. I'm going to pause this video because it gets too long to upload. So pause right here and go ahead and go to the next video. And also give yourself time to do this problem by yourself if you'd like.